Hi class, we're going to be talking about some different angles today, and the first one is the central angle. The central angle, the vertex of that angle is on the center of the circle. And I'm going to draw a little picture over here to the side. That central angle might look something like that. And when you're looking at this, then we have this central angle being here. We'll call it angle, so let's name the circle A. This would be angle A. This angle is splitting that circle into two different parts that we'll talk about in just a minute. Before we do that, though, we need to talk about the sum of all of those central angles. So if you think about like the whole way around a circle, we already know that. The whole way around is 360. The sum of all of those angles is going to be 360 as well. So if you're trying to find one of the angles, what I would do here is I would just know that this is 90. I would add up the three that I have. So when I add those up, let's see, that's going to be 215 degrees. Well, I could just take 360 minus the sum of all of them that I have. So that part that's left over is going to be 145 degrees. Things like vertical angles still apply. You don't have those here, but they might not look like they give you enough information, or if you have a straight line, we'll practice some of those on a little bit. Okay, the next thing we need to know is what an arc is. An arc is simply just a portion of the circle. And we have three different categories for arcs. So we can see that this central angle split it into these two arcs. So we have this one that's red, it's the smaller one. We have this one that's blue, that's the bigger one. The minor arc is the arc that's the smaller one. So minor arcs are going to be less than 180 degrees, or less than half the circle. The major arcs are going to be more than 180 degrees, and exactly half the circle would be 180. So a semicircle, you've probably heard that before, is half the circle. I'm going to put a couple more points on here, and you could add these on too, because I need to teach you how to name the arcs. For minor arcs and major arcs both, the name of the arc is the two endpoints. But we need some sort of way to distinguish where or which side we're going around. So the rule is, for minor arcs, you just use those two endpoints. So I could call this minor arc PR. And just like with lines or segments, you draw those on top, you draw a little arc on top. You do not need to include the B. You could say it's RP if you wanted to, but you use those two as the endpoints. And again, make sure you label this, because if you don't, you might think it's like the line segment going through, that chord. We're going to be talking about different parts of the circle and different sections, so just make sure you're being specific when you name that. If it's the major arc, though, you can't just use those two, because if you just have two, that's the short way. So if you want to go the long way around the circle, you're still going to have P and R, but you need some other point in between. So you could name it PCR or PAR, or even like if you started with R and went the other way. You don't need to include every point in between, but you need at least one more to show that it's going the long way around. So here's the way the majority of the questions are going to look from this section. The majority of the questions will say to identify them as a major, minor, or semicircle, and then find the measure. And they tell us here that PM is the diameter. So because this is the diameter, what I like to do first is I like to go through and just label everything. Because this is the diameter, that makes these two linear pairs and also these two linear pairs, so they're going to be supplementary. So this one's 90, That one's also 90. And then I can do 180 minus 115. This one is 65. Or if you didn't figure that one out, you could add up those three and take it away from 360 and get the same answer. So if I'm going from M to Q, I know right away that that's going to be a minor arc because it just has those two letters. And that arc is going to be the same measure as that central angle. So I need to write this. The arc measure equals the central angle measure. Make sure you write that down. That'll be really important. I should have probably made like a big box or something for that to help you remember. So this minor arc is going to be 65 degrees because that central angle that kind of intersects that arc is 65 degrees. For this next one, we have M, N, P. Well, that's half the circle. That's a semicircle. And that would be 180 degrees. And then this last one, I have M, N, and then it goes all the way around to Q. So this is a major arc. And you have a couple different ways you can think about this. Some kids just like to add up all of those different measures, so 90 plus 90 plus 115, and that would be fine. But somebody else might say, well, I'm going to take the whole thing and just subtract the part that I don't have. Either way, you'll get the same answer. Either way, that's going to be a 295 degree arc measured. And then congruent arcs, I'm just going to write down they have the same measure. And if you want to maybe make an example of that quick, we could do that. If you have a circle, actually let's add this in because we haven't looked at this yet. Let's say that I have vertical angles. That's supposed to be right through the center. Sorry, it's not quite there. Even if I don't know what these are, these two arcs, if that was the central angle, those two arcs would be congruent because these two angles are congruent also. Here in this example where it says bicycles, it shows us this circle graph. Otherwise, sometimes it's called a pie chart. Anyway, for the circle graph, it tells us what percentage of the circle each category is, but it doesn't say what the measure of those angles are. What you need to remember is we have 360 degrees total in the circle, and if we have some sort of percentage of that, you are going to end up multiplying that percent by the total number of degrees. And if you're doing that on your calculator, you probably also need to remember how to change the percent to a decimal. So let's just say, for example, I want to figure out what angle this is. So I would say 37% is the same thing as 0.37, and I'm going to then multiply that by 360. So I would go ahead and grab my calculator and type that in. This angle here is 133.2 degrees, and that would make this arc JK that same measure. So looking at these, the ones that they want us to find, this first one says find the measure of arc KL. So KL is this part. That corresponds with the 21% of the circle. So I would multiply 21%, or as a decimal 0.21, times 360. And again, I'm just going to my calculator and typing that in. Hopefully you're doing the same. This measure would be 75.6 degrees. So please don't think that it's 21 degrees. It's 21%, and remember percent means out of 100. This is out of 360. For the next one, it asks us about NJL. So starting at N, going through J all the way around to L. Kind of like that last one, you could either add up those three percentages, otherwise you could just take these two, and again, these are not the degrees, these are the percent. So if I want to add these two up to get 16%, it'd be 100% minus 16%. This would be 84% of the circle, and then multiplying that by 360, you get 302.4, and that's degrees. We've already been doing this next one where it says arc addition here. You can just write down that you can add adjacent arcs to find the total measure. And I've been doing that already, just kind of pointing it out. Like if you wanted to find the whole thing here, you could add up those three portions. Let's do one more example of that, and then we'll talk about the difference between measure and length. So looking at this, if I wanted to find these different parts, this is a 63-degree angle. This one would also be 63 degrees. If these are diameters, if this is a diameter here, I could find the one adjacent to it. Those are going to have to add up to be 180. So you could just take 180 minus 63. This is 117. And then for this other one, these aren't a linear pair necessarily, but all three of those angles or all three of those arcs are going to equal 180. So then you could do 90 plus 63 to get 153, and then just subtract that from 180. So this angle in here is 27 degrees. So then arc addition, if you wanted to find, let's say like BD, well then you just add the 63 and the 27 up, and then you would get that that's 90. So just different ways that you can come up with them. It's not like one's right and one's wrong, but we'll get the same answer no matter how we figure it out. This next thing, understanding the difference between these, is probably going to be like the most important takeaway, because different questions are going to ask you different things. So when we're talking about arc measure, the way that that's going to look is that might look like the measure of arc AB. This is talking about the degree. The size of the circle does not matter when we're talking about arc measure. You're going to have all circles are 360 degrees all the way around. So like the semicircle would be 180 no matter what the size of the circle. When we're talking about arc length, we're talking about like how far. So we're talking about like you're going to have some number of units. Like for example, like how many centimeters or how many inches or how many feet or whatever the units are for that problem. When you're talking about arc length, you have to know how big the circle is. Size of the circle matters for arc length. If you have, let's say, the diameter or the radius, if they give you one, you can always come up with the other. You have to know one of those two for arc length. I'm going to write out the equation for arc length and then explain why it is what it is. For arc length, you're talking about like the distance around the circle. So you're going to need to know the circumference. And I'm going to write it over here because that's the way I'm going to write the formula. Circumference is 2 pi times the radius, or you could write pi times the diameter. This is just the way you'll see me write it. But it's not the whole circle, it's whatever portion of the circle you have. So the way you can tell the portion or the percentage of the circle is figure out your arc measure over 360 degrees. This is the portion of the circle, or think of like the percentage of the circle it is, and then when you multiply that by the whole way around, that's going to give you the length of the arc. If you were going to get a tape measure and kind of wrap it around a portion of your circle, That's what we're talking about here. So the directions for these at the bottom say find the length of this arc. This arc is 45 degrees because the measure is the same as that central angle. However, that does not mean that that is like 45 centimeters if this is 3 centimeters. That just doesn't quite make sense. So what I need to do is I need to use this formula for arc length. So arc length is going to be the measure over 360. That's like the fraction or the percentage of the circle, depending on how you're thinking of it. And I'm going to multiply that by the distance the whole way around. So the whole circumference would be 2 times pi times the radius, which is 3. Make sure you grab your calculator. I'm going to grab mine and figure out what that is. Make sure that you're able to type this in right. Please use the pi button. You should get about 2.36, and make sure that you include units on this. You should actually be including like the degree if you're talking about arc measure also, but this here is going to be centimeters. So the answer to this, rounded to the nearest hundredth, 2 after the decimal, is 2.36, and that's centimeters. This next one I'm doing the same thing, but this next one, notice here how the whole diameter is drawn in. That makes 14 the whole diameter. So if you want to kind of figure out what the radius is for that formula, the radius would be 7. Finding the length of AB, that's 80 degrees for the measure. So I'm going to have 80 over 360. That's the whole portion of what that would be. And then multiply that by the circumference of the circle. So again, grab your calculator and type this in. You should get about 9.77, and that's rounded to the nearest hundredth. So I hope this helps. I know we'll have some questions probably when we get to those. Make sure you have your notes handy when you're working on this.